In the last part of Mod 4, we graph the secant and the cosecant. Remember that cosecant is the reciprocal of sine. So the easiest way for us to graph the cosecant is to go ahead and graph the sine function. Anywhere that the sine graph crosses the x-axis will be an asymptote in the cosecant function. Then the graph of the secant function will look like parabolas where one opens up and the next one opens down between the asymptotes that you have found. So let's actually graph the cosecant function. Remember the labels for the basic sine function. We started at 0, and we had pi over 2, pi, 3 pi over 2, and 2 pi. So those were the 5 marks that we used on the sine function. The high and low on the sine function, the amplitude was 1. So now to actually graph the sine function, remember it's at 0, 0, then it goes up to 1, back down to 0, down to -1, back to 0. So don't draw the full sine function, just sketch it in, do dotted lines, dashed lines, whichever way you want to think of it. So there's where the sine function would be. Now, these places where the sine function crossed the x-axis are going to be the asymptotes for the cosecant function. So we have a vertical asymptote at 0. We have a vertical asymptote at pi. We have a vertical asymptote at 2 pi. So now, where the sine graph went up, you will have a value of 1 for the cosecant. But instead of opening downward like the sine function does, the cosecant opens upward because the smallest value that it can have is 1. But it must stay between the asymptotes. At the 3 pi over 2, we are going to start at the -1 and then open downward and stay between the asymptotes. So those red parabolic looking figures are the graph of the cosecant function. Just like all the others, this could go on forever and ever to the right and to the left. This is one period of the cosecant function. So the period length of the cosecant is 2 pi. In the same way that we did the cosecant function, we are going to do the secant function. Since it is the reciprocal of cosine, we are first going to graph the cosine, find the zeros, which is where the asymptotes will be, and then create our parabolic shapes alternating, opening up and down. So the basic values on a cosine function are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Amplitude for a cosine function is 1. And then remember that the basic cosine function starts up at 1 and then goes down to 0, down to -1, back up to 0, and then back up to 1. So if we just sketch this in as a dotted graph, there's our cosine. So what that means now is that where we were at 0, which is at pi over 2 and 3 pi over 2, we will have vertical asymptotes. For the graph of the secant, we will find our 1, and then instead of going downward, we're going to go upward toward the asymptote. We will go to our -1, and where that opens up, we're going to reflect and open down, staying between our asymptotes. Go to the next 1, and then open towards the asymptote. Because we have two half pieces between 0 pi over 2 and then between 3 pi over 2 and 2 pi, that gives us one full piece, and then we have a second full piece between pi over 2 and 3 pi over 2. So this is one period of the secant function. We could keep going and have the other half of those parabolas going like so. But the graph of the cosecant, if you are only looking at one period of it, does not include that second little piece. What I have shown originally here now is the basic one period for a secant. How long did it take us to go through that one period? 2 pi. So the period of the secant function is also 2 pi. On example 11, we are asked to graph one period of y equals the secant of 6x. If you look at this, we want to think about a's, b's, and c's again. Since there is no number out front, a is 1. B is what's right in front of the x, which is 6. And there's nothing added or subtracted on the end, so there is no c. C is 0. So because we are going to use either the sine or the cosine to help us graph this, we are going to consider amplitude. Amplitude is 1, since a is 1. The period, you take standard period length. The functions of sine, cosine, secant, and cosecant all have a standard period length of 2 pi, and put that over b. Our b is 6. Well, 2 pi over 6 simplifies to be pi over 3. Our increments, we take the period that we just found, pi over 3, divided by 4, or times 1/4, and get pi over 12. Because c is 0, there is no phase shift. Since there is no phase shift, then we are going to start at 0 like both the sine and the cosine always do. Our increments are pi over 12, so that's what we need to count by. So we're going to add pi over 12s until we have a total of 5 marks, with 0 as our first mark. So add pi over 12, you're going to be at pi over 12. Pi over 12 plus pi over 12 puts you at 2 pi over 12, which is pi over 6. 2 pi over 12 plus pi over 12 puts you at 3 pi over 12, which is pi over 4. 3 pi over 12 plus pi over 12 puts you at 4 pi over 12, which is pi over 3. And we have our total of 5 marks, so we are done with our horizontal labels. How long did it take us to get through all these labels? Pi over 3. What was our period supposed to be? Pi over 3. So we're good there. Amplitude is 1. So we're going to have 1 and -1 on the vertical axis. Now let's think about what function this is. This is a secant, which is the reciprocal of cosine. So the first thing we're going to do is sketch a cosine, which starts up at 1, goes to 0, down to -1, back up to 0, back to 1. So here is your cosine graph. Now, where you have the zeros at pi over 12 and pi over 4 will be your vertical asymptotes. On the left end at 1, we're going to start at 1 and open up. At pi over 6, we're going to start at -1 and open down. And then at pi over 3, we're going to start at 1 and open up, going towards the asymptote on that. And now we have our graph of y equals the secant of 6x. For example 12, we are going to graph one period of y equals 2 times the cosecant of 4x. In this problem, our a is 2, our b is 4, and our c is 0. We have no c. Amplitude will be 2. Period will be standard length of 2 pi divided by 4, which simplifies to be pi over 2. The increments will be pi over 2 divided by 4, or times 1/4, which gives us pi over 8. And since c is 0, we have no phase shift. For our labeling, we have no phase shift, so we will start at 0. We are counting by pi over 8s. So 0 plus pi over 8 puts me at pi over 8. Plus pi over 8 is 2 pi over 8, which equals pi over 4. 2 pi over 8 plus pi over 8 gives me 3 pi over 8. 3 pi over 8 plus pi over 8 gives me 4 pi over 8, which simplifies to be pi over 2, and that's our 5th mark. Our period length was supposed to be pi over 2. Where did we finish our 5th mark? At pi over 2. So we're good. Our amplitude is 2. So our vertical labels will be 2 and -2. Since this is a cosecant, the initial graph we're going to sketch is the sine. So the sine's going to start at 0, go up to 2, back to 0, down to -2, back to 0. So there is the sketch of the sine function, where we have our zeros at 0, pi over 4, and pi over 2 will all be our vertical asymptotes. And then at pi over 8, where we went up to 2 on sine, we're going to start at 2 and open upward between our asymptotes. Then at 3 pi over 8, we are going to have a mark at -2 and open downward between our asymptotes. And there we have one period of y equals 2 times the cosecant of 4x. On example 13, we are asked to graph one period of y equals -2 times the cosecant of the quantity x plus pi over 2. In this case, our A is negative 2, our B is 1, and we do have a C this time. It is pi over 2. So amplitude will be 2. But remember, because A is negative, we will have to flip our function upside down. Period, we are going to take standard length of 2 pi divided by 1. So period is 2 pi. Anytime our period is 2 pi, then we use the basic increments of pi over 2. Our phase shift. I'm abbreviating here so I can fit this in. We need to do the opposite of C. So we're going to do negative pi over 2. Put that over the B, which in this case is 1. So that just becomes negative pi over 2. What that means then is instead of starting at 0, we are going to shift this whole graph to the left and start at negative pi over 2. Let's shift our graph over to negative pi over 2. This is where we're going to start now. Our increments are pi over 2, so that's what we are going to add consistently. Now remember, we still need a total of 5 marks. For our second mark, we're going to do negative pi over 2 plus pi over 2, which is going to put us at 0. So we will have a mark on the vertical axis at 0. That's our second mark. Add pi over 2 to 0, you're going to be at positive pi over 2. For mark 4, we need pi over 2 plus pi over 2, which is pi, or 2 pi over 2. Add 1 more pi over 2 to that, you're going to be at 3 pi over 2. Our amplitude is 2, so our vertical labels will be 2 and negative 2. This is a cosecant, so our sketch function will be a sine. But remember that we have to flip it because of the negative sign. Zeros will stay 0, so our first mark will stay 0. But instead of going upward for the second mark, we will go down because we are flipping. Go down to negative 2, then go back to 0, go up to positive 2, and then go back to 0. So here is your flipped sketch of a sine function, where we have the zeros at negative pi over 2, positive pi over 2, and 3 pi over 2 are vertical asymptotes. And then for our first mark at negative 2, instead of opening upward as the sine does, we're going to open downward, staying between our asymptotes. And then at pi, we're going to be at positive 2 and open upward between our asymptotes.